Now, a real definition of a chemical change is that we have bonds being made or broken between two atoms. Now, we're going to have that come up in just a moment, but first we're going to start at the macroscale, and the reason is that we can't observe the microscale directly. And we've already got some experience, probably, in identifying chemical changes based on macroscale phenomena. This is something you've been doing since elementary school, in all likelihood. Now, let's take a look at some of these rough guidelines. Now, keep in mind, you're going to need at least two of these under normal circumstances to be able to think that it's a chemical change. If you just have one, that may not be a chemical change, and I'll show some examples of that here in a second. So production of light is one of the things that could indicate that you've got a chemical change. An example of that would be when I set something on fire. I am tearing apart the material and oxygen and recombining them to form carbon dioxide and water. However, just because you give off light does not mean that you had a chemical change. One example of that would be when I heat something. If I warm something up like a toaster filament, the toaster filament didn't react away. I passed electricity through it, it got hot, and it started to glow a dull red color. So by itself, production of light does not mean that you have a chemical change, but with some others it could. And now a change of temperature, that's another indicator of a chemical change. Now together, production of light and change in temperature often means that there's a chemical change, like my examples I just used a moment ago, fire. And just like the example I used a moment ago, the toaster, it does not always mean that it's a chemical change. Now, a change in state accompanying these things is also sometimes an indicator of a chemical change. Anytime you have something going from a solid to a gas, for example, if I spark gunpowder, it's going to suddenly create a change in state. It's going to go from solid to gas. There's going to be a flash of light, and there's going to be a change of temperature. That will be a chemical change, but we can also identify cases where we can have a change in state and a change in temperature and production of light. Maybe I took some metal and heated the metal until there's production of light. Now notice in that example, the change in temperature was because I heated it, not because something about it caused the temperature change. It's all about whether you do it to it or whether it's able to do it itself. Now a change in color, again, like I said, you gotta have two or more of these. Now that gets the juices flowing a little bit for things that look like they might be chemical changes. And it's something we can use as a starting point. But we really want to focus things down to the microscale, especially when we're thinking conceptually in a course. Now, the real definition of chemical change, the parts of a substance, in other words, the atoms, or the large ions, if you have a polyatomic ion or something, become attached in different ways. In other words, there's new or broken bonds between atoms. So you're making or breaking bonds. That's our true definition for a chemical change. Now that's not going to innately change the spacing the same way that a physical change does, but it probably will in a lot of cases. Not all. We'll see lots of examples of that as we move forward. Also, when we change the attachments of those of the atoms in that molecule, remember, the interactions of the smallest parts of your system give rise to all of your higher level properties. If I change my attachments, it's typically going to have different properties. Now, look back up the top half of this slide, and you'll see that's the kind of thing we were talking about moments ago. It's just we didn't have a reason behind it. Now you see there's a reason behind those top phenomena that we've brought up, and it's the underlying phenomenon, the microscale things are causing that.